Very good morning. Today we are going to solve certain problems, some simple problems in economic load dispatch problem. I hope everyone with your notebook and pen and also with your scientific calculator. So we'll straight away go with the problem. So this is one of the example problems. Solve for economic load dispatch of generation for a total demand of 850 megawatt. Solve for economic load dispatch of generation for a total demand of 850 megawatt. The unit 1 is coal-fired steam generating unit, and the heat rate characteristics. The heat rate of 3 generating units is given. The heat rate of 3 generating units is given. In that, particularly, the first one is the thermal, that is coal-fired generating unit. Okay, this heat rate of first generating unit is 510.0 plus 7.2 P1 plus 0.00142 P1 square rupees per hour. Okay, the minimum and maximum operating limits is 150 megawatt less than or equal to P1 less than or equal to 600 megawatt. Actually, I missed the unit here, so you just mention clearly. So 150 megawatt less than or equal to P1 less than or equal to 600 megawatt. The fuel cost of first generating unit, that is thermal generating unit, is 1.1. Okay, 1.1 rupees. Okay, because here the heat rate is given in rupees, so this fuel cost also it is in rupees. Next, the heat rate of second generating unit. Second generating unit is 310 plus 7.85 P2 plus 0.00194 P2 square rupees per hour. The minimum and maximum operating limit is 100 megawatt less than or equal to P2 less than or equal to 400 megawatt. Then the fuel cost of second generating unit is 1.0, that is 1 rupee. Okay. Next is heat rate of third generating unit. Third generating unit is 78 plus 7.97 P3 plus 0.00482 P3 square rupees per hour. The minimum and maximum operating limit of third generating unit is 50 megawatt less than or equal to P3 less than or equal to 200 megawatt. Then the fuel cost of third generating unit is 1.0 rupees. Okay, so this is the data that is being given in the problem. So here heat rate is given, then fuel cost also given. So how to calculate the fuel rate equation? So the fuel rate equation is nothing but heat rate into that particular fuel cost. So what you have to do is, so you have to calculate F1, F2, and F3. 3 generating units is given. So for 3 generating unit, you need to calculate the fuel rate. Okay, fuel rate equation. So F1, F2, F3. So what you need to do is F1 is equal to H1 into this particular fuel cost. So F1 is equal to fuel cost of first generating unit is 1.1. So 1.1 into this particular heat rate. Okay, so which will gives you the, so here if you see the fuel cost function of 3 generating. So the first one is F1 of P1 is equal to H1 of P1 into 1.1. Okay, that is fuel cost of first generating unit. So whatever the equation that is being given, H1 into that particular fuel cost 1.1. So which gives you the answer like F1 of P1 is equal to 561 plus 7.92 P1 plus 0.00156 P1 square. Similarly, the fuel cost of second generating unit, F2 of P2 is equal to H2 of P2 into 1.0. Okay, so 1.0 is the fuel cost of second generating unit. So whatever the heat rate that is being given into 1.0. So which gives the same answer almost. So 1.0 means same answer. So next fuel cost of third generating units, that is F3 of P3. So F3 of P3 is equal to H3 of P3, that is heat rate of third generating unit into that particular fuel cost that is being given in the problem. So which gives you the particular answer. Okay, same answer. It is also being given. Okay, so if the in the problem, if the fuel cost is not given directly, heat rate is given, you can also take it as rupees 1 or $1, like that you can simply take. If it is given, you have to take that particular fuel cost only. Next, what is the general formulation that we derived in the previous equation? That is dFi divided by dPi is equal to lambda. That is already we derived. Okay, in the previous class we already derived, that is economic load dispatch of n thermal generating unit. So we have seen like n thermal generating units. In that we derived, that is differentiate the fuel cost with respect to that particular generating unit and equate it to lambda. Okay, so what we this is the general formulation. So we have to differentiate. That is here I is equal to 1, 2, 3. Why? Because 3 generating units only we have given. So only 3 generating units we are going to solve. So the first generating units dF1 divided by dP1 is equal to lambda. So what we have to do is we have to differentiate the fuel cost of the first generating unit and so fuel rate of first generating unit, and we have to equate it to lambda. So while differentiating, what we are doing is we are differentiating and equating it to lambda. While differentiating, this term will becomes 1. Okay, so this constant term we can differentiate. So 7.92 plus, so this term is also there, that is 0.001562 P1 square. Okay, so if you differentiate this into 2, okay, so this term into 2. Okay, so if you differentiate, you will get like 0.00312 P1 P1, that is equating it to lambda. So take this as equation number 1. Okay, for easy understanding. Next, similarly, we have to differentiate the fuel cost 2 with respect to P2 and equate it to lambda. So what is the equation? F2 of P2 is equal to 310 plus 7.85 P2 plus 0.00194 P2 square. So similarly, we need to differentiate and equate it to lambda. So here, if you see like 7.85 plus, if you differentiate 0.00388 P2, that equals to lambda. So don't cut short here. That don't after decimal, whatever the terms, whatever the terms coming here, you just put all the terms here. Okay, don't confine to 1 or 2 decimal points. Okay, don't round off. You take all the, why? Because if you round off, don't round off anything. Why? Because that's why use scientific calculator. Whatever the term it is coming, the same term you just utilize. That you take it as equation number 2. Similarly, you have to differentiate that is fuel rate of third generating unit and equate it to lambda. So similarly, what we are doing here, we are differentiating this term 78 plus 7.97 P3 plus 0.00482 P3 square, and we are equating it to lambda. Okay, so while differentiating, you will be getting 7.97 plus 0.00964 P3, that equated to lambda, and you take it this as equation number 3. So next, total demand. So in the question, so you have to note down this total demand. Where is the question here? Yeah. So here this is the question for a total demand of 850 megawatt. So total demand in the sense it combines all the 3 generating units. So whatever the not only 3. So how many generating units given in the problem, that equates to total demand. So here in this problem, only 3 generating units only given in the problem. So what we have to do? So 3 generating units, that is P1 plus P2 plus P3 is equal to 3 generating units, that we have seen in the power balance constraint. What is power balance constraint? Whatever the power generation that is happening, that equals the demand. So here, whatever the power generation happening, that is 3 generating units. So we are taking P1 plus P2 plus P3 is equal to 850 megawatt. Take that as equation number 4. Similarly, what we are doing is here, equation number 4. Yeah, the total demand is 850 megawatt. So what we are doing is we are taking P1 plus P2 plus P3 is equal to 850 megawatt. So take this as equation number 4. So we have now 4 equations. So different, whatever the differentiated with respect to particular that particular generating unit, that equals the lambda for 3 generating units, and as well as this 4th equation. So from equation 1, we have to take down this P1 outside. So that's all. So next all are mathematics only. Next you have to solve, you have to go back to your 8th standard mathematics, and you need to solve this equation. That's all. Okay. So now this thing is over. Next you have to do with you have to play with your mathematics. So from the equation 1, you have to go, you have to take this P1 outside. So P1 you have to take outside from equation 1, P1 outside. So if you take P1 outside, that is P1 is equal to lambda minus, so you have to take this term outside. So minus 7.92 divided by 0.003124. Okay, so this is the P1. So for better understanding, you can take this as equation number 5 also. Okay, next, similarly, from the equation 2, we have to take down the P2 outside. So if you take down the P2 outside, P2 is equal to lambda minus 7.85 divided by 0.00388. So that is from P2. Similarly, from the equation number 3, so you have to extract P3. So P3 if you take, so from the equation you need to solve. So from that equation P3 if you take lambda minus 7.97 divided by 0.00964. You can also take this as equation number 6 and equation number 7. Okay. So from the equation number 4, we are already seeing like P1 plus P2 plus P3 is equal to 850. So what we need to do is we need to, you have taken equation number 5, 6 and 7. You need to substitute equation number 5, 6 and 7 in equation number 4, or otherwise you need to substitute P1, P2 and P3 in equation number 4 over here. Okay, so after substituting, so this equation becomes like this. So we have to substitute. Next also full of mathematics. So we need to calculate lambda. So this term, this term alone, you need to take outside. So what I'm doing is I'm just taking this term outside. That is, I'm taking lambda divided by this whatever term that is coming over here. That has one side, and minus this term as another side. Okay. So so what I'm doing is I'm taking the lambda terms one side and other terms outside. Okay, these are all mathematics only. So this is one of the technique. Whether you can do some other thing also as simple as possible also you can do. But as of now, this is somewhat easy for you to solve. Okay, why? Because you can also directly solve this using scientific calculator. The thing is that if you miss 1 or 2 terms, then so better you separate this this numerator denominator like that. So that you can easily solve. So what I am doing is I am taking the lambda terms one side and other terms another side, equal to other side. So while simplifying, after simplifying, so you need to solve all those things by using your scientific calculator. Next, by simplifying, I am getting the equation like this. Okay, I'm getting the equation like this. After further simplifying, you can get lambda is equal to 9.1482. Okay, after decimal, you take four terms. So that will gives you the accurate answer. Not a very accurate answer. Some accurate answer you can get. Okay, for very accurate answer, you have to take after decimal whatever the terms coming, but it will come like 9 terms, 10 terms. But if you go for 9 terms, 10 terms, time consumption also will be increasing, and also it is very difficult. Every time you need to enter 9 terms, 10 terms. So after decimal, hereafter after decimal, 4 terms you take. 4 terms you take. So for getting very accurate answer. Why? Because we are dealing we are dealing with a megawatt. Okay, so if you round off for 2 terms or 1 term like that, so you can also take like a 9.14 like that. So what happens is, after while solving the problem, at the final answer you'll get 0.5 megawatt. You'll get less. Okay, so 0.5 megawatt is very huge amount. Like 0.5 megawatt is 0.5 into 10 to the power of 6. Mega means 6 into say 10 to the power of 6 watts. So 0.5 into 10 to the power of 6 watts, it is getting lost. Okay, like that the answer will be. So so what you need to do is very important thing while solving almost all of the problems in this particular subject. So what you need to do is, after decimal you have to take 4 terms. Don't round off. Don't round off any terms. So whatever that is coming in the scientific calculator, that after decimal 4 terms you write, you'll get some 99% accurate answer. Some tolerance limit is that I will tell you. Okay, so after getting lambda, so what you need to do is you need to substitute. You need to substitute in the equation 1. Okay, equation 1 for calculating the power generated from the first generating unit, that is P1. P1 is power generated from the first generating unit. Okay, that is in megawatt. So what we are doing is we are substituting lambda. We are substituting lambda in this first equation. So we are getting some answers like this. And also while getting answer, also don't round off. Don't round off to 1 or 2 decimal points. So whatever the answer, like 4 decimals, you just write. If 3 decimals is coming, no problem. So approximately I'm getting P1 is equal to 393.164 megawatt. Like that I'm getting. So you will also get the similar answer to this. Okay. So next, you need to substitute lambda in the equation number 2. Equation number 2, you'll get same equation. What is from the equation number 2? I think P2 is equal to lambda minus 7.85 divided by 0.00388. So I'm substituting this lambda, that is 9.14 in this equation. So I'm attaining the answer as P2 is equal to some 332.47 megawatt. Similarly, similarly for P3 also. P3 I need to substitute the lambda over here. So while substituting, so we are getting like P3 as 121.36 megawatt. Okay, while doing, you will get accurate answer. So the thing is that next what we need to do is we need to compare the answers within the, whether it is falling under the minimum and maximum operating limits or not. Minimum and maximum operating limits. And also once you check the answers, like, so whatever the answer you are getting, say for example P1 is equal to we are getting like a 393.164 megawatt, P3 332.47 plus P3 is equal to 121.36. So you add and you just find out whether it is satisfying the demand or not, maximum demand. What is the total demand that is being given? That is 850 megawatt. So if you just calculate P1 plus P2 plus P3, so you will get like 849 point some 9 9.5 or 9.1 like that you will get. So why you are getting 849.91 something, some answer you will get. You will not get very accurate answer like 850 megawatt. Why? Because we have taken only 4 terms. After decimal, we have taken only 4 terms. If you take whatever there after decimal, say for example, if you are calculating P3, that is the answer is coming like 121.36871478 something you are getting in your scientific calculator. The same answer you are taking. Similarly for 3 generating units, the same answer you are taking. After that, if you are going for adding all this P1, P2, P3, you will get like in that scenario also you will not get 850 megawatt correctly. So if you add like that, you will get the total demand as 849.99999 some 7 or 8 like that you will get. Okay, so that is approximately equal to 850 megawatt only. It is approximately equal to 850 megawatt. Sometimes you will get 850 also while adding all this after decimal terms correctly, accurately. But why? Because your calculator is refining to, I think, 9 terms, 10 terms only. After decimal, you will get only 9 to 10 terms only. Your calculator is refined. If you are going for a super calculator like MATLAB, then you can get 850, 849.99999, around 850 also you can get. Okay, so after that you need to verify whether it is falling under the minimum and maximum operating limits or not. Whether it is falling under, that is the problem. So you need to go with the data of the problem, whether it is falling under this minimum and maximum operating limits or not. So what you need to do is you need to write like P1 is equal to some 314 point something megawatt, comma, what is the minimum and maximum operating limits. That also you need to write in the answer. Okay, so 150 megawatt less than or equal to P1 less than or equal to 600 megawatt. Next, P2 is equal to some other values. I think you got some values, comma, 100 megawatt less than or equal to P2 less than or equal to 400 megawatt. Next, similarly, like P3 is equal to 121 point something megawatt, comma, 50 less than or equal to P3 less than or 200. So what is the first generating unit limit? 150 to 600, 100 to 400, 50 to 200 megawatt. So we need to check. Okay, it is falling in the first generating unit is falling under this limits or not. Okay, so whatever the value we calculated, like, yeah, it is falling. Why? Because first like a P1 is equal to 393.164 megawatt, comma, 150 megawatt less than or equal to 600 megawatt. So it is falling. Okay, it is falling under 150 to 600 megawatt. So this answer is correct. Similarly, we need to check P2 is equal to 330. Yeah, this is also falling. I think 100 to 400 megawatt. I think so. Yeah, 100 to 400 megawatt. What is this? Yeah. Yeah, it is 100 to 400 megawatt. So this is also falling. Next one is 550 to 200 megawatt. That also we need to check. So you need to take down the answer and you need to write clearly. Okay, clearly you need to write. Yeah, it is falling under 100 to 400 megawatt. So this is also satisfied. Next, P3 also 50 to, I think, 200 megawatt. This also falling under the third generating limit. Okay, so you need to take so up to this, if you write now for say for example 10 mark question, up to this if you write now, only 8 marks only will be given. Only 8 marks only will be given, even though your answer is correct. So what you need to do is you need to take down all the answers outside and you need to write comma, thus comma, and also minimum and maximum operating limit for 3 generating. That also you need to write. Okay, that you need to write. And conclusion, you need to write the conclusion also. So what you need to write the conclusion? So P1, that is power generating unit 1 and power generating unit 2, comma, and power generating unit 3, that is P1, P2, and P3, satisfies the power demand, okay, satisfies the load demand or power demand, and also it satisfies the minimum and maximum operating limits. Like that, conclusion also you need to write. So this also carries 1 marks, and the answer what you have written, no, answer with some minimum and maximum operating limits. So that also carries 1 mark. So 8 plus 1 plus 1. So 10 marks. Okay, 10 marks will be awarded. So if you write up to this, don't come to me, sir, you have given only 8 marks. I need 10 marks, full 10 marks. I won't give you. So only thing is that if you satisfy all the things, that is conclusion, and as well as your the answers and also units. Units is very important. Megawatt. That also you need to specify correctly. So sometimes in the urgency, like while writing fast, you will forgot the units. Okay, for if you not write the units, I think 3 to 4 marks I will be reducing, even though the entire answer is correct. Okay, and you have written the conclusion, everything. So 3 to 4 marks I will be reducing only for the units. Why? Because we are dealing with megawatt. Okay, it is not simply watt. Okay, the answer is wrong only, but some 4 or 5 marks I will be reducing if you not mention the units. Why? Because there is a difference between 121 megawatt, sorry, 121 watts and 121 megawatt. Okay, say for example, I need to give 121 lakhs for you, but only I am giving 121 rupees for you. Whether you will accept or not, you won't accept. Similarly, like this also, we won't accept. Why? Because we are calculating in megawatt. Okay, instead of giving 121 lakhs, I am giving only 121 rupees for you. Whether you will accept? No. So similarly, in this problem also we won't accept. So only 5 marks will be given for the step marks. Okay, only you solved correctly. And also one more thing in the problem. Sometimes what mistakes you will do is, if you say for example, if you miss 1 or 2 terms, and you can also solve the problem. Sometimes the answer will come in negative, minus. Okay, the answer will come in negative, say for example minus 1100, and P2 it will come, P1 it will come like minus 1100, then P2 it will come like minus 800, then P1 P3 it will come like some 700 or 800, like that. So if you say for example, I am telling, so if you add all these things, all those things like P1 plus P2 plus P3, so it will also come like approximately, say for example 850 megawatt, it will also come like approximately 847 megawatt or 846 megawatt, like that. Also sometimes it may come, the answer is wrong. And also it will not come in minus. That you need to understand, that power generating units, it will not come in minus terms. Why? Because if it is coming in negative term, so the thing is that it is taking the power from the grid. Okay, you need to supply, generating station has to supply the power to the grid. You should not take the power from the grid. Okay, so what is the use of taking the minus? Means you are taking, say for example 1000 megawatt, you are getting P1 as minus 1000 megawatt. That is, the thing is that what is the thing is that you are taking the power from the grid. That is 1000 megawatt you are taking from the grid. That is generating station. It is taking 1000 megawatt from the grid. It will not happen. So your answer is wrong. Okay, so you need to verify again. So no need to do 1 or 2 times the problem in the exam. So that's why I'm repeatedly saying, like decimal points, after decimal points perfectly you need to note down the integers thing. whatever the coming in the calculator. Sometimes while taking from the calculator, like the answer will be like 210.9489 something it will come. While writing, you will miss one or two terms. Then the deficit will come like while adding, instead of 850 megawatts, like 849.9 something has to come. Instead of 849 point something, you'll get 848 megawatt or 848.5 something like that. You will get say for example, you are getting, instead of 850 megawatt, you are getting 848.5 megawatt. So how much megawatt is the deficit? The megawatt of deficit is 1.5 megawatt. That is 1.5 into 10 to the power of 6 megawatt deficit you are getting. Okay, so 1.5 megawatt is not at all a easy task to generate. Even that too requires more amount of energy to generate. So that answer is wrong only. Wrong only. Why? Because the tolerance you have to get like 0.5% tolerance you can get. That is admissible. Okay, 0.5% tolerance you can get. That is admissible. Like 849.5 and above you can get. I think that also you should not get. But for exam point of view, I'm telling 849.5 and above, it is permissible or acceptable. But it should not go below this term. It should not go below this term. But generally, if you follow my technique, like after decimal 4 digits, if you take, you'll get like 849.9 and some terms. Okay, like that also you can get. That is correct, accurate, correct. You'll get full marks. So you should not cross. And sometimes you'll be extraordinarily doing the calculation. You'll get, instead of, say for example, demand is 850 megawatt. Those who are doing extraordinarily with your playing extraordinarily with your calculator, sometimes you'll get 850.5 or 850.2, 850.1 and all. Some extraordinary students will get some answers. So that is also sometimes acceptable, but it should not cross. Why? Because we have given the formulation for only 850 megawatt, but sometimes you will get due to some calculator error, or while taking and writing you will miss one or two terms, or you add some terms, and instead of you'll round off also. Sometimes the answer will come like a 390.19 some megawatt, like that it is coming now. So instead of 19, what you will do is 390.9, like that. You miss that term after decimal 19, but you will write in paper like 310.9 like that. So in that extraordinary case, you will get 850 and above also. That is demand and above. Whatever the demand that is given, that above answer also you'll get. That also you should not get. That also wrong. So that's what you have to very careful while doing LCM, that division, everything. You have to be very careful. You are not doing, but scientific calculator only doing. So you no need to worry about that. You need to enter correctly. That's all. You'll get accurate answer. You'll get full marks in that this particular